Hi guys, I'm Bob. In this video, I'm going to show you the solution to the integration of tangent x over 1 plus tangent x dx. But before I do so, if you guys like the solution, let me press thumbs up icon below this video so as to beat the YouTube algorithms and rank this video on the top of the search. And do consider to subscribe to this channel for more integration problems. For this particular problem, what we're going to do, first step, we are going to multiply in the numerator by secant square x. And we do the same to the denominator, which is to multiply by secant square x as well. Then using what we know about the trigonometry identity, Pythagorean, that the secant square x is equals to tangent square x plus 1. And then we apply this formula into my secant square x in the denominator. We get the following. Then we can apply the technique called the integration by substitution. How do we go about applying it? We let u be equals to tangent x and we differentiate u with respect to x. This gives us secant square x. When multiplying both sides by dx, we get du is equals to secant square x dx. So once we get these two formulas, we can substitute by changing all the x's into u's. So we have the following. The secant square x dx, we get du. Tangent x is u over 1 plus u squared plus 1. Now from here, what we're going to do is we are going to use another mathematical theory called the partial fraction decomposition. So how do we go about doing the partial fraction decomposition? We split this u over 1 plus u squared plus 1 into the following, which is big A over u plus 1 plus big B u plus big C over u squared plus 1, where my A, B, and C are constant. And then when we make u the subject, we just multiply both sides by u plus 1 times u squared plus 1. So we get the following, which is u is equals to a u squared plus 1 plus bu plus c u plus 1, in which we simplify, we get the following answer. Then to find out what is my constant a, constant b, and constant c, we compare the coefficients. So we get the following. So we get a plus c is equals to 0, b plus c is equals to 1, and then we have a plus b is equals to 0. So after evaluating all this, we found out that our a is equals to negative half, and my b is equals to half, and my c is equals to half. Then we substitute back into the this thing. So my u over 1 plus u squared plus 1 is as follows, which is the integral of basically negative 1 over 2u plus 1 plus u plus 1 over 2u squared plus 1 du. From here we take out the half, which means that we factorize the half, and then we get the following, which is half the integral of minus 1 over u plus 1 plus u plus 1 over u squared plus 1 du. And then what we're going to do is we're going to split this up into two different fractions. So we get the following, which is minus 1 over u plus 1 plus u over u squared plus 1 plus 1 over u squared plus 1 du. Basically from here, I'm going to erase the left hand part of the answer. So after this, from here, what we're going to do, we are going to split this integral out into three different integrals. The first integral will be half the integral of u over u squared plus 1 du. The second integral will be the integral of 1 over u squared plus 1 du, subtracting away the integral of 1 over u plus 1 du. So as for the first integral, what we will do is we will multiply 2 on top and at the same time half out the integral. So we get the following. Alright, from here we can proceed on to evaluate what is the integral. So for the first integral itself, the integral of 2u over u squared plus 1 is just ln absolute u squared plus 1. For the second integral, the integral of 1 over u squared plus 1 du, that gives us tangent inverse u. Whereas for the last integral, the integral of 1 over u plus 1, we get ln of u plus 1. And then plus c. Last but not least, we substitute u as tangent x. The reason is because my question is expressed in terms of x, so we have to change everything back. So we get the following answer. And we are going to further simplify the whole thing. So how do we go about doing that is, for the first term, my tangent square x plus 1 is actually secant square x. Because based on the Pythagorean trigonometry identity, that tangent square x plus 1 is equal to secant square x. Tangent inverse tangent x is just x. And last but not least, we have subtracting away the ln of tangent x plus 1 plus c. Alright, and from here, the first term, we can actually bring this half up, so we multiply the power. In the end, we'll get just a ln secant x plus x, subtracting away ln absolute tangent x plus 1 plus c. Then we combine the lns together. Okay, so what we get is as follows. We get the following, which is ln secant x over tangent x plus 1 plus c. Alright, and this is the final answer to the integration of tangent x over 1 plus tangent x dx. If you guys like this solution, help me press the thumbs up icon and don't forget to subscribe to this channel for more integration problems. Thank you guys for watching, and I will see you in the next video. Goodbye guys.